Hi and welcome back to class 2 of Python scripting in Cinema 4D. This time we're going to follow up on what we learned in class 1 and have a look at the Python generator, which you can find under script and Python generator. Now, big difference you see straight ahead is that we didn't generate an object in advance and added a tag to it, but instead the Python generator itself seems to generate the object, which it does. And that's already one of its major differences to the Python tag. Now, if you remember, the Python tag in class 1 was used to modify the object that was underneath it or that it was attached to. The Python generator, on the other hand, is in itself the object. So if we look at it here at the code, it's opened in the editor, and you may have noticed I've changed the layout a bit because it was getting a bit crowded in the last class, and I hope you can now see everything clearer. So anyway, if you look at the source code, there's really not much in here. It's just importing the c4d module, and then it's doing really nothing except returning a c4d base object of type cube, which is what we see here. So this is what the Python generator does. It automatically calls its main function and then does anything in there that it wants, but in the end it expects to get an object as a return value. So this object can be really anything at all. There are all kinds of objects there, like the cube, or we can change this here to just say, oh, sphere. And if you compile it and execute, there we go, now we have a sphere. And you can even just, if you don't want to see anything, just return a null. There you go. So that's the basic use of the Python generator. You run your script, you do all kinds of calculations, and in the end, you feed it into an object and return that object, and that's what's being generated and shown in the viewport. Now, another big difference is that the Python tag from class 1 was evaluated on every frame. So on frame 1, if you remember correctly, we were using the frame number as a variable to modify the object underneath. With the Python generator, this is a bit different. The Python generator is meant to generate the object on frame 0, and after that, do nothing with it anymore. So it's just generating it here, and then once you play it, it's just another object, and the script's not being run anymore. And you can see here some options. The most important one being this one here. So normally, let's create something that we can see again. So let's put the cube back in. So normally, when you go back to 0 and you had changed something to the on the cube, when you go back to 0 and this is checked, then it's just regenerating the object and we're back. If you uncheck this, then once it's generated, it's not being regenerated until you press force update. So what I've planned for this class is for us to generate an object based on a source object of any type, then play with that object a bit, change its points, change its positions, and then feed it back into the Python generator and have our own modified version of that object. So how do we do that? First of all, well, we have the generator already in here, but we need an object to get our data from. So to do that, we will generate a sphere. So this will be our source object. And I'm going to drag that underneath the Python generator. This does nothing right now, but we can get to this object from here. And it's actually rather easy. To understand how we get to this, we have to go back into how Cinema handles objects within its object manager. So you have to think of these as a, well, exactly as you see it here, as a tree-like structure and as a list of objects. So when you're in this object here, you could walk down that list to the next object and grab it and go back, which is exactly what we're going to do. So let's try this out. And just like before, we're going to print the output so we can see what's going on. And in our case, now actually another difference to the last time. If you remember, last time we used the OP object, so the op, to access the tag, and then from the tag went to the parent object. Now in this case, the parent object itself is a Python generator, so we don't have a tag in here, so op in this case is the object itself. So let's just execute this to show you, and you can see here op is the Python generator, which is this one here. So we don't have to go one level back down, we can just use this here. So op is this. Now let's go one down. So this is really easy, it's called op.getDown. And let's see what it does. So first, op is still the Python generator, and one down is a sphere. And there are a couple of these commands to navigate through the tree. And let me just show them to you. Just like last week, we find the base object class, which, as you can see again here, the Python generator is also part of. So let's go back. So the base object class is this one here, and the base object inherits everything from the base list2d and from the GE list node. And the GE list node, that's the one that's going to be of interest to us just now, because when you click on that one, you can see we get these navigational functions here that will let us navigate through the object tree. Now the one I used just now was getDown. Let's see what it says, and it returns the first child of that object. So it's going down not on the same level, but it's going down, let me show you again in here. So it's not going down from here to, let me just generate another object. Not from here to the cube, but it's going down to the first child, which is the sphere. And you have a number of these. Now where this goes to the first child, this one would actually go to the next object, wherever that is. So this one would go first to the sphere, and if I call getNext again, it would get to the cube. This one is also quite interesting, because this one will return to you a list of all the objects that are children of that object that you are currently reading. So if there were more than one object in under the generator, like let's say I have a sphere and the cube down there, and I were to call getChildren, let's do this now. And clean this up. Right. So you can see this generated the sphere, so that was getDown. It will only show us the very first child, and this one will give us a list of all the objects that are underneath, so sphere and cube. Right, and then there is of course another way to get to an object, which is not using these functions, but which instead is going to use the document itself. So on the document, you can go to the base document, and in there is a, where is it? Here it is, search object. So let's click on that, and it's very straightforward. You're just going to search for an object by its name. And let's do this. So print doc, if you remember, doc is already preset with the currently open document. So search object, and well, let's search for sphere. So again, this is looking at the name, so if I were to call this source sphere instead, this is not looking for the type, so let's see what this says. Compile, execute. Sorry, let me just clean this up so it's cleaner. Well, hello. There we go. Right, so here we have our source sphere, and you can see it's the exact same object ID, and yep, so it's finding that sphere, that's this way. But because we want to stay flexible, for our purposes, this is the ideal command, because this means that whatever we drop into the generator here now, doesn't matter what, it will return that object that's next in the list. So this is going to be our object. Actually, let's call it source object. Alright, so we could already change this now into source object, because this one returns a base object and this one expects a base object. So this should now, oh, okay, let's get rid of this print. Compile, execute. The cube was on top of it. Okay, so there you see, it's now showing me that object. And actually, to show you that we're not seeing this one here, but the actually generated one, we can hide this one here. Now there's a bit of a problem, because if I hide this now, this is actually showing us nothing at all. And the reason for this is that the Python generator is actually taking this now as a source of the object, but because it's hidden, this one is going to be hidden as well. So it's not working this way. What we have to do is we have to take the source, make a clone of it, and return that clone, and hide the source object. So to do that, there's another command, which is also part of every base object, and it's called getClone. So this will return the sphere, the source sphere, and make a clone of it, and that's going to be our source object. So let's see if that works. It does. And now we've broken it. Why did we break it? Okay, I'm not entirely sure what happened here. Let's just regenerate that sphere. Where's it gone? There. Drop it back in. Hi, and now it seems fine. Interesting. Well, I'm going to look this up, and if I find out what this was and whether this is a bug maybe, I don't know. I will let you know. In the meantime, let's stick with this for now. So, right, we have our clone, and now the first thing we should do, because if there's nothing in here, we don't want to run into any problems later on, so we should check whether anything was returned at all. So we can just check this by if source object. So if our object is none, meaning it's an empty object, there's nothing in there, we will just return a base object of type null. And this, by the way, is a capital O, not a 0. So this means that if there's nothing in here, like this, okay, right, we should have not called the clone here, because you can see here now we're getting this error, that exactly the type of error that I was trying to prevent. Because if this is none, so if nothing was in here like it is now, then we will get this error when we try to work with that source object, that, well, it's basically telling me that all kinds of functions are not available for the none type, because none is nothing. So let's get rid of this getClone at this point. So we just get the object that's underneath the Python generator, in this case nothing. We check whether there's anything in there. If there's nothing in there, we just return a null. So you see now this is not complaining anymore, because what we get now is a null object. And if not, we just continue. So now we say source object, equals source object dot get clone. And now it's good. Okay, so now we have our clone. What we also wanted to do, of course, was to hide the source, but make visible the result. So as usual, we can just check the visibility options in here and drag them in here. And there you see it. And the same for the renderer. Right. And we want to modify our source object, so there. And that's actually not quite true, because we are already working on the clone, so this is not the one we want to modify. So let's make this slightly different. So let's not call this source object, let's call it clone object. So this way we now have the clone, which we get from here, but we also still have the source, which is this one here. And what we want to do is we want to hide the source object and not the clone object. And this is what we're going to do now. So this, and let's copy this here. And now what's interesting is these do kind of look like, because you can turn them on and off here, they look like booleans, but they are not. What they are is a drop-down that is numbered from 0 to, well, whatever. They can have all kinds of IDs, but in this case, these are numbered from 0, 1, and 2. So if you want to turn it on, it's 1. If you want to turn it off, it's 2. And if you want to leave it as a default, which means it's going to inherit from its parent, then you leave it at 0. So in our case, we want to turn the source off. And let's copy this. We want to turn the clone on. So let's see if this works. Alright, so apparently I was telling you lies. So it actually numbered the other way around. So 2 is the default, 1 is off, and 0 is on. Yes. So make of that what you will. It makes no sense at all if you ask me, but okay, let's just something to remember. So 0 is on, 1 is off, and 2 is default. Oh yes, of course. It's because I introduced this clone object here, but I was still returning the source object, so I have to, of course, return the visible clone now. So let's see and try again, and now it works. And again, that sphere has disappeared. What is going on here? This should not happen. It's very weird. And you see, it's really only happening sometime. Huh. No, it's staying. So I would probably count this as a bug. Tell me if I'm wrong, but I think it's a bug. In any case, let's just hope it stays for a bit and continue with this. So, right, now we have a clone of the original object and we can start to work with this. And what I want to do is I want to look at the points of this object. So these points here, which we can't see right now because this is still a primitive, and modify the position of those points. Now, like I just said, we are using a primitive, so you can't change the points of primitives until you make them editable and make them a polygon object. Now, I don't really want to do this now because I want to use all kinds of source objects here and only make them a polygon object internally, edit them and output them. But I don't want to touch the source object. And how can we do this? It's actually quite easy because we already have a clone. We can just change that clone into a polygon object and work with that while leaving the original alone. Changing the type of an object is relatively straightforward, but uses a slightly complicated command. The command is called send modeling command, and what that does is it's basically sending the exact modeling commands that you can use in here, all these commands, to an object and executes them. So the modeling command that we're looking for is the command current state to object, which will turn your object into an editable version of that object. And in the case of our sphere, we will end up with a polygon sphere. Now, to call that command, you have to import the c4d208 class or call it straight from here by using the c4d208 command. And we will just use that now. So that's just called send modeling command. And like this. And the kind of options you have to take are documented in here. Let's go to the top, into the utils, and it's right at the top here, send modeling command. And you see there's quite a lot of stuff to look at and plenty of commands you can issue. And you should really take your time and look at all the different commands you can use and all the parameters you can pass on. But for now, we will just use the one I just showed you, the current state2 object one. And to do this, we use this kind of syntax. So instead of just putting all parameters comma separated in here, we actually use the name of those parameters to make sure we know what parameter is doing what. So the command that we're going to issue is called c4d command, which stands for modeling command. And again, you see that in the list of the documentation. And underscore current state2 object. And there you go. And you notice you've typed it correctly when it's being highlighted. Next is a list. And the list is basically this is going to be the input to the modeling command. So you would expect it to read in a single object and work on that, but it doesn't expect a single object, it expects a list of objects. In our case, we only have one object, but we still have to wrap it into a list, which is very easy in Python. You just put it into square brackets. So our object is called clone object. And close the bracket. Actually, let's make it like this. The next parameter is the base container. We don't really have to look into this. All you need to know is just type bc, and it's called c4d.base container. And again, this is very annoying. It's scrolling not quite far enough. So we just generate an empty base container. A base container is just a generic class within Cinema that can contain all kinds of data. And it's usually being used to save parameters for an object. So any object has a base container containing its parameters. So let's take our source object. It has a base container, which is this dictionary thingy here. And in its base container, there is a parameter called ID base object visibility editor, and its value is 1. So that's what the base container is. It contains the parameters, and we just pass in a brand new one, and that's fine in this case. And the next one is important. Actually, let's just break this up for now, and we make it into a single line later on, just so you can see what I'm typing. So it's called mode equals c4d modeling command, command mode all. So it's going to affect all of the object. See, all means it's using all points and all polygons, not just the current selection. And then doc is the document that that object is in. And in our case, it's just equals doc because that's already preset for us. And we don't want to set any flags, so that's just 0. And we close the command. And now we have to make it into a single line again because... are we okay? I think we are. Right, so this very, very long command is going to take that object in and run current state2 object on it, and will return a result. And that result is what we're looking for. Now, that result is not going to be just the object. The result is going to be, again, a list of objects. Potentially only one object, which is the case in our case, because I can show you what happens. When I run current state2 object on a sphere, you will end up with a single object. That single object is going to be returned in a list, so it's only one object in a list. However, if you have a more complex object, like, let's say we were to put this into, no, maybe not that. Let's take a text and put that into an extrude. Now this is a bit more complicated. If I were to change this into a current state to object, you end up with, well, 3 objects. So in that case, the result here would return a list with this object here that has 2 child objects. So that's something to keep in mind. In our example, we are dealing with very simple primitives that will only return a single object. So we are fine with just assuming that the very first object in the result will be the one we're looking for. And again, just like up here, we will check if there's anything coming out the door. So that's if result, and we're looking at the first entry in that list is none. Then again, we will just return a null, and we know it has failed. Otherwise, we just continue, and we know that in the first returned result is at least not none, it's probably our object, and hopefully our polygon object. And yeah, so we can check that actually by not returning this one now, but returning this one now. Let's compile this, execute, and I think, yeah, no error message. And we have still our object here. So that seems fine. Now let's have a look at how to edit that object. First of all, we have to get the points. So by converting the sphere into a polygon object, we moved it up the ladder. Let's have a look at the c4d again. From our base object, we are now having a polygon object. Now the polygon object, as you can see, is also a point object. So while in the polygon object we have functions to access the polygons itself, we can't access the points directly in here. So if we look at the polygon, that will, actually I'll show you, that will return either the ID of that polygon, which in turn will just return the ID of the points that the polygon consists of. That is not what we're looking for. What we're looking for is the points itself. So, but because this is also a point object, we can use the functions inherited from this here. So we go in here, and there we get a number of functions that all access the points of the object. So we want the get all points, which will just return a list of vectors. So all the points don't have any attributes other than their position. So a vector is just a position in this case, which is also the point. So with that knowledge, we will just go and read out the points. So points equals result 0. And actually, because this is really annoying to type, let's just call this one now poly. Right, so we get poly get all points. And to see that it has worked, we will look at all points. There we go. Now we get all the points from that sphere. And it's a number of them. Right, let's do something with them. First, we should probably check how to get these points back into the object, because at the moment we just read out the points and have them in this list here, but we don't actually change the object itself. So if we change the values here, all we do is change that list, but the object won't take notice of it. So let's look into the documentation again, and below the get all points is a set all points, which will take a list of points, which is exactly this list here, and we just feed it back in. And this is a very important note you should really remember, because after you change the object, you have to tell Cinema that the object has indeed changed. And for that, you can send a message from the object to Cinema, and tell Cinema that, well, the object have updated. So this one we just copy and paste. Let's go back and Right, so we don't forget it. And let's just set all points with our points list. Now this should not make any change at all, and it doesn't, because we just took the points and put them back in. Now let's use the random function that we used last class as well, and that has a function to shuffle a list. So our list is called points. Sorry, and we should of course do this before we set them. Points.shuffle. Sorry, that's the wrong way around. So random shuffle points. So let's see what happens. Whoa! But you can already see this works. So what this did is just randomize the position of each point in the list, which then caused all the polygons to go all over the place. And if you were to render this, this will look rather weird. It's not exactly what we were looking for, but it will prove does prove the point that we are accessing the points now. So this is cool. Let's comment this out again because we don't want that. But we will use the random function. So what we want to do is we just slightly want to modify the position of each point. And again, we will create two user data fields, just so it's more convenient for us to play around. There's two. Let's call them random min and random max. There we go. And they are going to be float sliders. Real 0, 0, 1 and from 0 to 1. This one's going to be real. And also 1. Alright, so we have two sliders now that we can use. And let's set our random seed again. We could have used a slider for that as well, but that's something you can try out later on. Let's just set this seed to 1, 2, 3, 4. And let's get ren min. And of course this is from the original object, so that's going to be op, so that's from the generator. And max is the other field. Alright. Okay, so now we have two values and we want to change our points, so we use a for loop for that. And yeah, so actually, no, this won't work. This is a bit of Python, really. If I were to loop through the points by returning just the points itself, this would return p as a vector. And if I were to change the vector, well, it would change that vector, but it wouldn't change the vector in that list. So what I need to do is I have to loop through the list and change the entry in that list, so that back when we pass the list back into the polygon object, the changed entries are actually in there. So instead what I'm going to do is I'm going to use, let's call this ID, and we're going through points, but we're going through a range of numbers from 0 to the length of points, meaning that if we have 100 points in our list here, this will now start counting at 0 and will stop at 99. So length is 100, that's the last number that we'll count on, but it won't include that one. So this is counting from 0 to 99, so we have 100 in total. And ID is going to be that number that this returns. And this way we can then change the points ID. So this is going to change this particular entry in the list we get from get all points. And it's going to be, actually let's just take the original point as it is and then multiply it with a random number, and not a random number like last time where we just took a random number from 0 to 1, but we will take a random number between min and max, so our two sliders up here. Alright, so we will take the original position, randomize it a bit, and write it back. And when we're all done, we're setting the points and updating the object. And let's see if that actually works. Well, it doesn't. So global name I is not defined. Line 32, where are we? Oh yes, my mistake. This should be ID. Aha, now this looks interesting. First of all, notice all the points or the polygons are still attached to each other. So that's because we didn't change the order of the points, we just changed the position of the points. And now if I am changing these values, you see that we get interesting results really. And if we change both to 1, we have the original one, because this will return a random number between 1 and 1, meaning the original position. But if you play around here, you get really interesting results. And of course, to make it a bit nicer, we can increase the number of segments, and you may have to go back to frame 0 this way, okay, so it's being updated. But now you get some really cool dents. And of course you could then put that into a hyperNURBS. And well, I'm not sure what this looks like, but it's interesting. It may be looking better if we use, let's see, different type of sphere. Yeah, absolutely. So now we have a nice, oh, I don't know what it is. Right, but as you can see, this is really just a few lines of code and will let you randomize all kinds of geometry. It doesn't have to be a sphere, it can be anything. We can put a figure in there. Let's see what happens with that. Okay, something very weird happens with it. This is probably because, let's see. Yes, see, good example really. This is being returned as all kinds of sub-objects, and we only change one of them, which is this one. Because we are just looking at the very first one in the list here. So what we technically should do is we should also connect all of these into one single polygon object and then start shuffling around the points. That's probably something you can try out yourself, because I think in this class we've already run out of time. But I hope the concept has become clear. So just to reiterate, what we do is we take an object, and let's get back to the beginning here so it's not so confusing. Get rid of all of this and update. There we go. So what we do is we get an object from here, that's in here. We get it, we hide it, and we make a copy of it, and we unhide the copy. Then we change the copy from being a primitive, like this one here, into a polygon object using the send modeling command, by which you can send all kinds of modeling commands to Cinema. But in our case, we send the current state to object. Then, if we actually get something back, we just take the first of the results, which in case of a simple primitive, which will always be the right one. But with more complex objects, you will have to go through the list and find the correct one. Then we take the polygon object and get all its points in a list. We then change the points in that list, and we put that list back into the object, and we update the object, et voila. Actually, this should be the same. Yes, so you noticed I forgot to change from poly to result 0, but because they were both pointing to the same object, didn't matter. But generally you shouldn't do that. So you should always name your return values and everything correctly. So this was my mistake, but in this case it didn't make a difference. Right. Again, I think the time's up, but I hope this was interesting to you, and there's definitely plenty of stuff to play around with here, and I'm really hoping and looking forward to your results, and I'm hoping you're going to experiment with this. There's plenty more stuff you can do. You can have a look at the documentation, not just the points, but also the polygons. Like, let's go back, go to the polygon object, have a look at the get polygon command, have a look at the C polygon object, which will return points as well, the point IDs of that this polygon consists of, and then you can start shuffling those around and see what happens. Really cool and interesting results you will get there. Of course, not all of them will work, but it's really something you can play around with. And you can see here you can get really nice organic objects and randomized objects, or just really build your objects from scratch by creating a list of points and then creating a polygon object from it. So yeah, lots of possibilities. Again, just like last time, I'm hoping to see you again in the next class, and have fun with FXPhD and Cinema, and goodbye.